Welcome, everyone. Let's go ahead and take a look at these two examples. So we'll be working out these two integrals. I hope you have been introduced to the derivative of inverse functions. So this is the table that you want to make sure you have it in memory. Of course, you can derive them, but memorizing, especially these three, can be very useful, especially when you're doing integration. So we know that the derivative of sine inverse, it's going to be 1 over the square root of 1 minus x squared, which means we can modify a little and get a formula for integration. For instance, if you want to integrate, let's say, 1 over the square root of 1 minus x squared, something like this, respect to x, then we know that this will give us sine inverse of x plus the constant c. So that's how you will work with differentiation and integration. So if you integrate on this side of the formula and you get tangent inverse with plus c, of course. So knowing these six formulas very well, we can now go into these two examples. So I'll start with the very first one. So with the little help using U-substitution, we can do this integral and make it somehow look like one of these guys. So if you look carefully, they seem to look like this one. So let's see how that's going to work out. So I'm going to go ahead and do the following substitution. So let's use the U-substitution method. And if you have not seen this method, I will leave a link in the description box for you to check it out, review it, and then come back to do this problem. So I'm going to let U to be just cosine of 9x, not the entire piece, just this, because you will see why. So if I let U to be cosine of 9x, then my derivative of U respect to x will be negative sine of 9x times 9. So that's chain rule. So that's negative 9 sine of 9x dx. Now we almost have that, as you can see right here. That is going to be the substitution for du, but there is a negative 9 that's extra. So we can divide both sides by negative 9. So negative 9, 1 over negative 9 du will replace the sine 9x dx. So that's my substitution. And that will transform my integral into 1 over 1 plus u squared with the multiplication of negative 1/9. Now, because it's a definite integral, you could also change these bounds since they belong to x. You could change it or not. That's totally up to you. I'm going to go ahead and change the bounds. So when x is equal to 0, that's the lower bound. What is u? Well, u is equal to this. So let's go ahead and substitute the x value. So u will be cosine of 9 times 0, which will give you cosine of 0. And we know cosine of 0 is 1. And when x is equal to pi over 18, what is u? U will star. Well, it will be cosine of 9 times pi over 18. And that would give us cosine of pi over 2, but we know cosine pi over 2 is 0. All right, so these are the new bounds, the lower bound and the upper bound, as we transition this integral into the new variable u. So our integral in the new variable, this will be, I'll pull the negative 1/9 out, the integral. So this is replaced with du and the division of 9, negative 9 on both sides. So that will give us 1 over, and then cosine of 9x, that's simply u. So this will become u squared and du. So hopefully you can see that this gets the replacement of negative 1/9 du, and u is equal to cosine of 9x. And we have our new bounds. So we can also put them in there. They'll go from 1, that's the lower bound, and upper bound is 0. All right, so that's how the integral looks like. Now you just continue with this new variable, no need to go back. This is one way to do it. So this integral, as you can see, it is in the form that we mentioned right here. So if you integrate this side, so looking at number 3, if you integrate this side respect to x, well, we know it's going to give us tangent inverse of x with the plus c, because it'll be considered an indefinite integral. This is a definite, so we'll have to evaluate from 1 to 0. So this will be negative 1 over 9. And we know this is tangent inverse of u, not x, and evaluate it from 1 to 0. So that's how you use the formula. You make it look like one of those formulas on the table. And then you plug in the upper bound. So we have negative 1 over 9 tangent inverse of 1 minus 1/9 tangent inverse of 1. And we know, I'm sorry, this should be 0. Tangent inverse of 0 because we plug in the upper bound first. So if I evaluate tangent inverse of 0, we know, well, that's going to be 0. And then minus, that's going to be a positive 1/9. Tangent inverse of 1, we know that's pi over 4. So pretty much from pre-calculus, you learn that tangent of what angle give you the value 1 within the range of negative pi over 2 to pi over 2. So that's the number that will make sense. We know then this will evaluate to pi over 36. And that is our value of this definite integral. Go ahead and try this one on your own. We're going to be looking at this indefinite integral. So there's no bounds. Now it looks like one of the formulas we mentioned above. Now so if you have them in memory, you know that this kind of look like this looks like this formula. So if you integrate some constant, let's call it 1 over the square root of 1 minus x squared dx, we know that this is going to be sine inverse of x plus c. So it looks like that. So you just need to make it look like that. So how do I do that? Well, I can definitely rewrite things. For example, this right here, I can rewrite it. So I'm going to go ahead and rewrite it as a power of 2. So we know we can rewrite it as the integral. This is t to the 6 dt over the square root of 1 minus, I want to write it as something squared so that it matches this form. So we'll have to do t to the 7th because by laws of exponents, this is t to the 14th power. Okay, so that works. So then now this becomes your u. So we'll make our substitution. Let u be equal to just t to the 7th. Then the derivative of it is a 7t to the 6 dt. And that's exactly what we have here. That's the substitution with the adjustment of the 7. So that means if I divide both sides by 7, I have 1/7. du is equal to t to the 6 dt. All right, now we're ready to substitute everything back. So we know u is replaced by that. And then we know 1/7 du will be replacing this guy. So our integral now becomes the following. So we have the integral of 1/7 du over the square root of 1 minus u squared. Pull out the 1/7 outside of the integral. So you have the integral of, now you could write the du after. So this is really 1 over the square root of 1 minus u squared du. And this is exactly the match we have. So we know this is going to be our sine or sine inverse of u. So we know this is 1/7 sine inverse of u plus c. And then we finally substitute what u is. U is t to the 7th. So we know our final answer for this problem is 1/7 sine inverse of t to the 7th plus c. And there you have it. So I hope this is making sense. Try out with the different formulas, play around with them, running your substitution, and you should be able to figure out which inverse trig it becomes after the integration. All right, I hope this makes sense. Take care, everyone.